seen the confidence interval, and our goal is to predict the probable limits for mu. So we did probability that the mu is expected to fall between the two numbers is going to be the sea level, right? The sea level could be any number. So we got the lower limit and then the upper limit. So what is the formula? The formula that we used is C star plus or minus square root of n, which is the margin of error, the second component, and the first component is going to be the estimate, which is the sample mean. That is correct. Or you can also say that as estimate plus or minus margin of error. So this is what we have seen in the first half of chapter 14. The second half is going to be the testing of hypothesis. So what do you mean by hypothesis? So if I ask this question, generally the students will say this is going to be the meaning of the hypothesis according to the dictionary. It is going to be the educated guess. That is correct. I agree that. So this is the literal meaning of a hypothesis, which is the educated guess. But here now, when you are given a statement, so the educated guess is going to be on the statement on you, or you are going to be checking the statement on you, or you can say the claim on you, or you can say simply the sentence on you is going to be tested. So the statement or the sentence or the claim all are equivalent. So that is going to be tested, and we are going to be looking for some evidences provided by the sample data regarding the claim or the sentence or the statement on the population mean u. For example, I can say the human body temperature is a 98.6. That is a statement on view. The human body temperature, if I say 98.6, some people can say, no, it cannot be 98.6 all the time. It could be more or it could be less. So that is going to be the contradicting statement for the population mean mu. So here I am going to look for evidences or proofs based on the sample data to accept or reject the statement on mu. So that is going to be done here in testing of hypothesis. Any test is going to have some test procedure, or I can call that as the recipe. So there is a recipe here in order to do the z-test for the population mean mu. Again, here my condition is going to be when sigma is known. When the population standard deviation is known, I am going to talk about the test procedure for the population mean mu. So here the recipe says you need to define the two types of hypothesis. One is going to be the null hypothesis, the other one is the alternative hypothesis. So the null hypothesis is always going to be some statement or the sentence about mu. As I said, I'm going to say the human body temperature is mu is equal to 98.6. Yes, that is the statement. And what is the negation statement? The negation statement is opposite of the given statement. I can say there are three types to say that. Whether I can also say no, it could be less than, because in mathematics, if it is going to be the equality sign, in negation to the equality sign, I can say, hang in there, the one note is gone, it's coming. Right, right. Okay, so it's coming, hang in there. Yeah, good. So it's not that hard yet. Okay, so once the tablet gets so hard, I cannot. It will take some time, but now it's okay. So in negation to the equality sign, there are three signs in math. It could be less than, or it could be greater than, or it could be not equal to. So in negation to the equality sign, we have three types of sign available. Oh, that's good. I will try to do that. That's good. Good idea. I never thought about it. Okay, thank you. All right. I do have a lot of ice pack. I will do that. Yes. Thank you. Okay. You are going to have the alternate hypothesis is going to be one of the three, not all the three. One of the three. It could be mu less than mu sub zero, and that's going to be called as a Lafferty test. The other one could be mu greater than mu sub zero, and that's going to be given a name called the right tail test. And then if it is not equal to, then it's going to be called as the two-tailed test. So the two-tailed test includes both less than mu sub zero or greater than mu sub zero. So that includes both cases. All right. Again and again, I'm telling you, this is the application of your central limit theorem. Okay. So the step number 3 is going to be the z-score. So recall chapter 13 for quantitative variable. For quantitative variable, you are going to have the z-score, which is z equal to x bar minus, in the place of mu, I'm going to plug in the value as mu sub 0 over sigma over square root of n. So you know what is what. X bar is the sample mean, mu sub 0 is the value taken by your population parameter mu or the population mean mu, and sigma is the standard deviation and then known sigma. So the sigma is the standard deviation over the sample size is going to be square root of n. So this is my z-score, which is not new to you. You are all familiar with the z-score that we used in chapter 13. All right. This is new. What is new? The new concept is the level of significance. In the first part of chapter 14, I introduced C, which is the level of confidence or the confidence level. And here in testing of hypothesis, I'm going to be introducing the new number called alpha. So this is again the Greek notation, Greek letter, and this is called as alpha. This is called as alpha. All right. So alpha is defined as a probability of rejecting the null hypothesis when it is true, and otherwise it is called as the type 1 error. So I will come back to this point later, but usually, like how we fix the number for confidence level, which is the 90 percentage or 95 percentage or 99 percentage, here this alpha is the complement of your confidence level. So this alpha is usually 5 percentage. When you talk about the 95 percentage confidence limits, this alpha is going to be 5 percentage. Alpha could be 10 percentage. When you talk about your confidence level as a 90 percentage, the complement of the confidence level is 10 percentage, or sometimes the alpha is going to be 1 percentage. When you talk about the confidence level with the 99 percentage, this number is the complement. So basically, when you talk about the middle 95 percentage, you are bringing the 5 percentage, that's going to be your level of significance. When you talk about the middle 90 percentage, the remaining 10 percentage is what you are calling it as alpha, the level of significance. When you talk about the middle 99 percentage, that leftover 1 percentage, we are calling it as alpha. Somebody has some question, please unmute and then you can go ahead with your question.
Yeah, I just want to clarify. Is alpha always the complement of the sea level?
Correct. It all depends on your sea level. So suppose if your sea level, the confidence level is a 95, then you are going to, because when you are able to accept the probable limits for mu 95 percentage, I'm talking about the zone where it is going to be rejected. That is going to be the 5 percentage. When you talk about the middle alpha, that is in my confidence interval, I introduced that as, some books will call that as 1 minus alpha, which is the confidence level, but I used my C as confidence level because your TI is going to ask you the C level. Instead of 1 minus alpha, I used the letter C. The C stands for the confidence level. So according to TI, I use that as C level. So you can also use 1 minus alpha. So what I'm saying is, if it is going to be the 1 minus alpha confidence level, that's going to be your C level, and then this is what I'm calling it as my alpha. So this point is going to be my alpha over 2, and this point is going to be my alpha over 2. That is what I call it as the level
Scroll
of
down
C.
just a little, please.
Oh, sorry.
Thank you.
Okay. So this is what I'm going to be calling it as alpha. You will be seeing it in my notes, okay? All right. So this alpha, I told you that it is going to be usually 1% or 5% or 10%. I will come to this one later, okay? Now, with two numbers, because you are going to have one probability value, and that's going to be coming from your z-score. The z-score is going to give you one probability value, and another probability value is the preset number for alpha. As I said, is going to be usually at 5% or 1%. Very rarely it is going to be about 10%. All right. When we talk about the 90% confidence limits, then your alpha is going to be 10%. But usually we are happy with the 95% confidence limits, so that way my alpha is going to be 5%. If we talk about 99%, then your alpha is going to be just about 1%. That is correct. All right. So now we are having the z-score in step number 3. So that z-score is going to give you the probability. So this is the cutoff point, and the left tail test, which is going to be mu e less than mu sub 0. That means you are going to get the area to the left of the z-score, which is normal CDF negative 8 comma z. I'm putting my favorite number, which is negative 8, and that is going to be compared with my alpha. And so the conclusion is coming here. If my p value, the probability value that my z-score is giving, and that probability value is going to be compared with the alpha, so if p value is less than or equal to alpha, I am going to be rejecting my null hypothesis. Meaning, smaller the p-value, smaller the p-value that my sample data is giving, I am going to reject my null hypothesis. So smaller the p-value compared to alpha, it is going to give me a very, very less likely probability. That way, I am going to reject the null hypothesis. But if my p-value is pretty strong, stronger the p-value, I do not reject my null hypothesis. Or I can say fail to reject my null hypothesis. So again, my alpha is going to be 5%, and with the 5%, I'm going to be comparing with my p-value. If my p-value is giving me a smaller probability value as compared to the alpha, and I'm going to be rejecting my null hypothesis. And at the same time, if my p-value is pretty strong, it's going to be accepted. So that is the concept in your testing of hypothesis. So now what is the other one? The other one could be mu greater than mu sub 0. So if mu greater than mu sub 0, then it is going to be my z-score comma a, and that's going to be my p-value. So the p-value is going to be falling in the rejection zone, or I can say if p-value is less than alpha, again the same conclusion, it is going to give me a less likely probability value, then I would reject my null hypothesis. And if p value is pretty strong, greater than alpha, then I would reject my null hypothesis based on the sample data. So in both the cases, my conclusion is going to be whether to reject the null hypothesis or to accept the null hypothesis. So if again, smaller the p-value, I am rejecting my null hypothesis. Smaller the probability value or the less likely probability value, I refute my null hypothesis. Stronger the probability value, fail to reject. You can say fail to reject, or you can also say do not reject the null hypothesis. So this is what is going to be done if you were testing the hypothesis. So it involves some 5-test procedure. You are going to have null versus alternative, and the second one is going to be the z-score, and the third one is going to be the alpha. Alpha is going to be usually given in your problem, like how we get the confidence level number as 90%, 95%, or 99%. This number alpha will be usually given in the problem, say 5%, say 10%, say 2%, say 1%, like that. The number is going to be given in your problem, and then you are going to use your sample data to get the z-score, and then with the z-score you are going to get the probability. Now this probability value and alpha are going to be compared. Smaller the p-value, you are going to reject your null hypothesis. All right, so this is what is explained in your diagram. So here my alpha, hang it there, it's coming. Okay, so now this is what I call it as the rejection region. So this is the rejection region. Alpha is going to be called as my level of significance, and this is, oh, come on, something wrong with my OneNote. It's giving a lot of troubles today. So the procedure is obviously, lengthy process. You may not understand what I'm saying about, because the concept as such is going to be difficult when you learn it for the first time. But I'm sure next week you will be, getting much better idea about this concept. Okay. So obviously, every single concept when you introduce for the first time is going to be like Greek and Latin. I agree with that. But once you get comfortable with doing more and more problem, you will be okay with that. Okay. All right. So this is what I call it as the rejection region. So the entire thing is going to be my acceptance region. So this is my acceptance region. So in the next diagram, what I'm saying is whatever is the probability value that I'm going to be getting for my z-score, if that is going to be falling in my alpha, so my alpha is going to be the rejection region. So this is the rejection region, and this is the yellow shaded area for my probability. So this is going to be rejected because the yellow area is the probability. So the yellow is the probability. Now it's getting hot. I think it's not working now. Again, okay. So this yellow is the probability. So this is the probability for the z-score. Probability for the z-score. Since my probability is falling in the rejection zone, I am going to be rejecting the null hypothesis. And the same way, you are getting another picture, which is the left tail. So this is what is going to be my rejection zone for 5%. So this is my rejection zone. This is the rejection zone. This is the rejection region. And how about my probability? The probability is falling in the rejection zone. So this is my probability And if my probability is falling in the rejection zone for the given z-score, then I will reject my null hypothesis. So smaller the p-value, I'm going to be rejecting the null hypothesis, right? So where is it? It's giving some issues. So this is the rejection zone. Alright, so if my probability value is smaller and if it is falling in the rejection zone, I will reject my null hypothesis. Okay. Alright. So now let's come back to what is the type 1 and type 2 error. The type 1 and the type 2 error concept is very important. I have a tiny example here, and this example will help you to understand. So in any decision making problem, there are always going to be two types of error that is not avoidable. So in any decision making problem, because you're going to decide, right, whether to accept or reject, right? So in any decision making problems, there are two types of errors that is totally inevitable. So what are the two types of error? One is called type 1 error and the other one is called type 2 error. So any decision making problem with accepting or rejecting, whether you decide to have it or you are going to reject it. So with these two options, so that's where your decision is going to be, whether to go for it or whether to reject it. Okay. There are going to be two types of error, and that is totally inevitable. And what are they? They are type 1 error and type 2 error. So now let's consider an example with. So the statement is going to be the defendant is innocent. Now that's what we are going through, right? With George Floyd, that's what we are going through, right? The entire country is now shaking because of these kind of errors that we have committed. Not we, the police have committed. The defendant is innocent, not guilty, versus the statement H1, the defendant is not innocent, he is guilty. So the evidences are presented in the court by the prosecutor, and based on the evidences, the jury decides the verdict whether innocent or guilty. If the defendant is convicted but he or she did not commit the crime, that is type 1 error. If the defendant is acquitted but he or she did commit the crime, and that's going to be called as type 2 error. Now everything is clear. Let me put that in a tiny table for our better understanding. So what is the tiny table in terms of a statistics language? So I am going to put the two cases. The defendant is innocent, not innocent, and he is convicted. So he is innocent, he is convicted. That is the bad thing that we did, which is called the type 1 error. All right. So what is the statement for type 1 error? The type 1 error is going to be rejecting the null hypothesis in terms of the statistical language I'm speaking. So rejecting the null hypothesis when it is true. I am rejecting it. So that is going to be one type of error. And what is the another type? I am saying accepting the wrong statement. Accepting the wrong statement when it is false. When it is false. So these are the two types of error. So either you could do rejecting the correct statement, or you are ending up accepting the wrong statement or accepting the false statement. So that's what we call it as the type 2 error. So this table tells you the type 1 error is he is innocent, he is convicted. That is the type 1 error. And what is the other one? He is not innocent, he is a guilty guy, but he is at large, he is acquitted. So that is going to be the type 2 error. The remaining two situation is the correct one. Yes, he did the crime. Yes, he is punished. He is behind bars. And he did not do any mistake. He is still at large. So these two are going to be the correct decision. And this one is called as the type 1 error. That means rejecting the null hypothesis when it is true is one type of error. And at the same time, accepting the wrong statement, it is called the type 2 error. So we always, now the another statistical language I'm using, we always minimize, we always try to minimize the type 1 error or the error that we are committing, and that's why we are keeping alpha is equal to the probability of a type 1 error. So once I attach a probability, then it becomes usually 5% or 1% or 10% based on your C level. Whereas in your confidence level, we always try to maximize the number. Whereas in confidence level, we are going to we maximize the confidence level. Maximize the confidence level. We never keep it as low. So now you know how they are complementing each other. So alpha is going to be the type 1 error, the probability attached to type 1 error, and that's going to be called as the level of significance. And the other number is going to be the confidence level, and that is used in your confidence limits also. Looks like Jessica, you had some question. I heard.
No, your mic was making a weird noise, but it stopped. I can hear you fine now.
Oh, okay. Maybe I'm just shaking the wires. I put it aside. Okay. Maybe I'm just shaking the wire. That could be the reason. Now it's okay?
Yeah, now it's perfect. Thank you.
Okay, good. I think my hands was moving and it was just moving the wires and everything, the speaker wires especially. I think I'm not touching it. It's kept aside. All right. So this is the concept in your testing of hypothesis. So that's it. So again, for this one, every single answer is in your TI. You don't have to worry about it. So you are going to go to stat, and then you are going to test, and then the very first option, Z-test. So that's going to be used here to get all these work. So you don't have to worry about anything. Everything is on TI. Only the concept that you need to know, what is the testing of hypothesis and what is the test procedure given to us. You know how to get the z-score using the chapter 13 material, and you know how to compare the p and alpha. So as I said, smaller the p value, you are going to reject your null hypothesis, because the less likely probability number is not going to show very good evidence for accepting the null hypothesis, so that we are going to reject it. Stronger the p-value, if p-value is greater than alpha, that means that there is a good indication that the null hypothesis is good to go. Smaller the p-value, reject it. That's it. So those are all the only two concepts that you need to remember here. Otherwise, everything is on. So now, just for example, because we have about 5 minutes, I'm going to show a simple example where it is going to be done. So I'm going to pick the last two problems, because the rest of the questions are multiple choice question. I made it very simple. I cannot make it simpler than this, but I am going to show you the last problem. So that way you will understand how undergraduate cost for tuition, and then the fee, room, for all institutions. So for all institutions, so that's my population. For all institution is my population under study. I'm talking about the tuition fees, room, board, and etc. Okay, and that one is given to me. So your mu is given. Your mu is given to be 26,025. That's right. Now, from this population with the mu is equal to 26,025, you are going to pick a sample. So the sample is going to be 40 institutions. So I see the sample, simple random sample of a 40 institutions is selected from the population under study, and what is the mean. So the mean is there, and the mean is going to be the number coming from the 40 institution, and that is going to be 27,690. All right, you are given another number, and that's going to be the standard deviation coming from the population, which is a 5492, which is 5492. All right, so you are given mu, you are given sigma, you are given the sample size, you are given x bar. That's all you need for finding the z-score, right? So let's work on z-score. If I continue to read the problem, yes, you are going to be checking at alpha is equal to 5%. All right, but now I need to choose what is the null hypothesis. So the null hypothesis is going to be always mu equal to mu sub 0. So this is going to be 26,025. That is the number coming from the population, and that is what is going to be kept in my null hypothesis. So what is that? The tuition fees and everything is going to be tuition fees, and then room, and then the board, everything is going to be 26,025. All right, now for choosing the alternative hypothesis, so versus the alternative hypothesis, so what is going to be tested? Now we are going to read the last sentence. At alpha equal to 0.05 level of significance, so you are going to test the statement, is there sufficient evidence that the cost has increased? So the increased is my keyword. The cost has increased is my keyword. So that way I am going to say it is what is going to be tested. So the cost has increased. So that statement is going to be tested. I'm going to look for evidences to see whether the cost has increased, and that's going to be the claim, or that is the sentence, or that is the statement that is going to be tested. Okay, so now the next step, I'm going to have the z-score, x bar minus mu over sigma over square root of n. So with all the numbers I'm going to get the z-score, and then the next one is the probability, right? And then once you get the z-score, obviously you're going to get the probability, and you're given alpha is equal to 0.5. So if your p-value is going to be less than or equal to alpha, you are going to reject the null hypothesis. So I'm going to take my ti, so turn it on, and then go to test, and then move on to test. Okay, so select option number 1, and again you have two options, data and stats. So this time I'm going to move on to stats, because the x bar is given, right? The number coming from the sample is given. I'm going to move on to test. Check, check, check. Just plug in the numbers. It is asking what is your mu value. So in the input screen, I'm going to plug in the mu value, which is 26,025. And then the next one, move the cursor down. It is asking what is the sigma value. The sigma value is 5492. Plug it in. And then it is asking what is the mean of the data. The mean of the data is given to be 27,690. 27,690. Plug it in, and then it is asking how big the sample is. You have the sample of 40, and then now you see the three options: mu not equal to mu sub 0, mu less than mu sub 0, mu greater than mu sub 0. So I am going to be selecting this option, which is mu greater than mu sub 0. So move the cursor to mu greater than mu sub 0. So that to be selected because you want to test the statement whether the cost has increased. So move the cursor down and then hit calculate. All right, and then hit calculate. So what do you see? So it is 26,025, and then the sigma value is 5492, and then my sample size, sample mean is 27,690, and then my sample size is 40, and then with that, what I'm getting is the z-score is going to be, what is the z-score now? The z-score is going to be 1.17. That's right. So this is the z-score, and what is the probability? So this is going to be the probability value, which is going to be 2706. So this is what I call it as the p-value or the probability. So when I compare this p-value with my alpha, what I'm saying is p-value is less than or equal to alpha, then I am going to reject the null hypothesis. This is the conclusion. You are going to compare the p-value with the alpha, and you are going to reject the null hypothesis because the 2.7% is less than 5%. So that way you are going to reject the null hypothesis. So when you are rejecting the null hypothesis, what about your claim? The claim is going to be accepted. So now your interpretation is going to be, yes, at 5%, I can say that the fees has increased. At alpha equal to 0.5, there is a strong evidence. There is a strong evidence to say that the fee has increased. The fee structure has increased. So that's what we are going to be concluding. That is your conclusion or the interpretation. So basically, we are testing whether the statement is going to be accepted or rejected. That's what is going to be done. Oh, I guess I'm so sorry. It's 12:23. I'm sorry, I did not realize the time. So anyway, I think I showed some example. One example how easy it is. Just for to make you comfort, I just showed one example. Who will continue tomorrow with the one problem, and then I will do that again. Okay. See you. Bye bye.
Thank you.
Sorry about that. Okay.